We've got here Sean from Sick Chips. I think that's what it's
That's
called.
me, yep. Sick Chips.
It's all trade secrets. How you going, bud?
Alright, yeah.
Everyone loves a Subaru with a turbo and, you know, the whoosh sounds of the blow-off valve, the box of rumble. These cars, they're notorious for having problems. The stock ECU is perfectly fine.
What do you guys do and how did you get around to doing this?
So yeah, Sick Chips, we do ECU unlocking, ECU unbricking. This is all stock ECU stuff for Subarus and Fords primarily. So we do on-site tuning or remote tuning, where, you know, remote we can put in a base map at the same time as doing the unlock or the unbrick, that sort of thing, to arrange everything so that the car sort of isn't out of their hands for too long. Yeah, in terms of on-site tuning, we come and do, I say we, it's just myself, but often it feels like it's we because it's a lot of work. Health checking, data logs, getting an idea of the vehicle's sort of current state before we go ahead and make any changes. Once we get an idea that, you know, all the sensors are reading properly, MAF, intake air temp, O2 sensors, front and rear, you know, wastegates functioning correctly. These cars, they're notorious for having problems with AVCS, so oil control valves seizing up, that sort of thing. We get an idea of how everything's working, make sure it's all functioning correctly before we make any changes, and then we'll go ahead and put in a custom calibration, or commonly known as a tune, for the ECU itself, taking into consideration any of the modifications that have been made, you know, for H6s like we're in today.
Speaking of the H6s and the, you know, the GT stuff, why do you choose to specialize in, you know, for example, Subarus and Fords in your line of work?
Oh, okay, yeah, good question. I specialize in Subarus because I have a bit of a love for them. They're sort of what I like to do just because I like that model of car. Subaru, box of rumble, all that sort of thing. It's a common, you know, talking point. Everyone loves a Subaru with a turbo and, you know, the whoosh sounds of the blow-off valve, all of that. But that's not to say I don't like any other car. Recently, we've been sort of branching out into other avenues, getting new software, that sort of thing. The Fords is something I've always done sort of in the background for various different workshops around Australia. Not so much publicly, but behind the scenes, I'm an electronics engineer. I have a big input and contribution to the open source community. So that's where the stock ECU side comes into play. In terms of adding functionality to the stock ECU. Yeah,
that was my next question actually. It was going to be, why stock ECU rather than aftermarket? Because you sort of emphasize it. And a lot of people these days are going after like the Haltech, the aftermarket stuff. Why are we doing stock ECUs rather than that?
Yeah, so like stock ECUs, these days you've got a lot of issues with, you know, immobilizers, CAN bus systems. The Gen 4 that we're in today, it's in that grey area of, you know, not quite CAN bus, but almost CAN bus. So there's not, yes, you can fit a Haltech to it, but there isn't so much you can do when it comes to, say, the automatic version. The 5EAT, it's got a specialized transmission control unit. The Haltech and other manufacturers, they're progressing to be able to interface with that unit and gain control. But at this stage, the stock ECU is the only one that can. You
can't just separate the two because they work together.
Yeah, that's it. There's so many different modules in the car that the stock ECU just works. There's really, as well, like, it's a bit of a, do you really need to replace the ECU for what you're trying to gain? Most of the time, you know, people talk about stage 1, stage 2, that sort of thing. So we're talking like bolt-on modifications. The stock ECU is perfectly fine.
Does that include like superchargers, for example, for this H6 model?
Depends on the size of the supercharger. Same with turbos. It depends on the size of the turbo as well. A lot of the times when you go, you know, all out, you fit, you know, a huge 3582 turbo onto a 2-litre 4-cylinder engine. You're gonna sort of lose control with the stock ECU and lose adjustability. As well, like you don't have the ability to see the numbers as quickly. So a stock ECU, it doesn't have the live tuning capability that an aftermarket one has. The stock ECU, it, you know, it can't spit out the data as quickly as you need it to. So if you're a tuner, that sort of thing, like that can gobble up a lot of time. Like you've got to go for a drive, take a data log, or, you know, run it up on the dyno a number of times, take some logs, pull up a spreadsheet, pull up your mega log viewer, that sort of thing, go through all the data sort of point by point on the screen and figure it all out. Whereas aftermarket, it's, you know, oh, there's a base map from the manufacturer of the ECU, You've got your live data on the screen. You can see the data points that it's hitting in live view, whether you're on the road doing road tuning or dyno tuning. An aftermarket ECU, you know, it's good in that regard. But if you're fitting, say, superchargers to a H6, the stock ECU, it will get you there to a point that the stock internals of the engine will sort of run out as well. So you know, it's a trade-off.
You're limited by what you have, like always, you know, when you're pushing powers, isn't it?
Yeah, that's it. You know, the engines are an air pump, air in, air out. You're limited by the engine and how much air it can flow as well. So yeah, in fitting modifications like that, the engine might be the first restriction rather than the ECU.
And for, say, for a stock, mostly stock cars that, you know, have a very simple exhaust system, like, you know, they replace the exhaust and all that, the intake and stuff, and they get a retune, or even if they didn't do any of that, would you suggest a retune for a factory model anyway, or for example for our Subaru cars anyway?
What I would suggest is starting with at least getting somebody who is familiar with data logging to look at the car. When you fit modifications that are outside the factory specs, no matter what it is, it might be a high flow cat or something like that, you're not really sure whether there's the correct air fuel ratios happening, or the wastegates sort of, you know, functioning correctly for the turbo, whether the turbo's spooling correctly. Closed open loop fueling as well, that's something that, you know, you can't really feel when you drive the car. So even like fitting a turbo back exhaust, you're now changing the characteristics away from how something worked when it was in stock form. So starting with, at the very least, a health check, depending on the scale of the modifications. Some modifications, you can get away with not tuning the car because they're still within the tolerances of the factory calibration. Ideally though, if you want it to last in the long run, you want to put the effort in the beginning to find somebody who's familiar with the platform that you're modifying and getting it adjusted.
Okay, great, thanks for that, Sean. The other question I would have is, for those of us who are, you know, basically enthusiasts for the H6 and the GT models, what sort of tuning are you doing for these guys? Because there's, you know, even though there's similar platform, but the engines are completely different. The components, the tuning, and all that's different. One's turbo, one's got 2 more banks of, you know, cylinders.
I do err on the side of, well, no, they're actually not too different, because they are just an engine. Anything can be tuned. It just depends on whether or not you've got the tools to tune it. Tools being, you know, correct data logging and monitoring. All we're doing is gathering the data and adjusting everything to suit how the engine wants to, you know, flow that air and that fuel through the engine. You know, people talk about stage 1 and stage 2 and stage 2 in infinity and beyond and that sort of thing. Every sort of custom calibration and that sort of thing is all put together on a case-by-case basis. Like, no car is the same as another, whether it's a GT or a H6. If we're tuning it, we're still taking into consideration the same things. We've got ignition timing, we've got air fuel ratios, we've got you know, engine load in different gears, we've got engine speed, we've got you know, going from cruise to non-cruise to, you know, wide open throttle under different conditions, part throttle, all that sort of thing. Everything you know, should be customized to suit that particular car. So they're not too different, but they're not the same. That's the sort of catch there. That's it. So at the end of the day, like I say, I don't do just Subarus. It's just I have a love for Gen 4 Liberties. Over the years, I've tuned everything from, you know, GSX R1000s that are race bikes for Australian superbikes with Motec ECUs. It's the same principle as what we're doing here with a H6 3-litre. Ram air intakes, you know, with a bike, when you gain speed, you're gaining air being rammed into the airbox. So essentially, you've got forced induction, but the forced induction comes just by hitting a higher speed. So
in a very stationary setting, that's not doable. Like, how do you replicate that?
Exactly right. So even with a dyno and that sort of thing, a dyno is a tuning tool, and so
it's still not the real environment.
It's not the real world. So with a dyno tune comes along road tuning as well. There will be some part of a road tune or some part of a road test at the end, whether it's before or at the end, or, you know, you'd want to hope that your dyno tune took that into account.
The dyno,
as well.
you don't currently offer dyno, do you?
I myself, I don't currently have a dyno.
But that's something you're looking into.
Yeah, so I'm exploring the option of, you know, having my own workshop in Melbourne and having a place where people can come to me and do that sort of thing. At the same time, I do work with a lot of workshops around Australia to hire out their dyno for, you know, a per hour basis. So if a customer comes to me, say with like a Nissan Skyline R35 GDR or something, and they're like, can we put it on the hub dyno, run it up, do a stage 2 on it, ECU, TCU tune, that's no worries, that's easy done. We just work with a workshop that is local to them. And yeah, most workshops are more than accommodating because, you know, they get, you know, some money for renting out their dyno, and I can ensure that everything's running correctly in a safe and controlled environment, and then take it on the street. You know, with a car of that caliber, it's a bit hard to hit higher speeds on the street. Obviously, we don't want to be going past the speed limit, that sort of thing.
So Sean, you're a professional, but for someone who's like, you know, someone who's just an amateur trying to look into doing the tune themselves, you know, downloading the open source softwares and stuff, do they run into some sort of risk, potentially brick their ECU or something? Is that something that happens on a daily basis, basically?
Yeah, that's right. That is a common problem, especially with Subarus. More so with Subarus and the way that the ECU, the code inside it has been written. When we break it down, we've got basically a bootloader and a main application. And so what happens in that is that when we read out both of those parts, and so the bootloader is the most important thing, and when we write it back in, the bootloader gets written first. So if at any point that bootloader gets corrupted, whether the cable comes unplugged, the battery dies, the battery voltage dips down or something, or, you know, you accidentally bump the hazard light switch or something when you're tuning, that can still happen. And so just some basics of having, you know, a battery backup, like a jumper pack connected to the battery, that would be a first start. If you're looking at interfacing with the electronics in your car, first of all, ensuring that the electronics in the car are up to scratch. That's the first start. So having a good battery, having a good alternator, maybe having a jumper pack connected or some sort of charger connected, so that way you won't run into the problems of bricking the ECU as easily.
It's like when your phone is updating itself, and then they like keep your power in, so it doesn't just corrupt when it's trying to, you know, update the ROMs and I don't know, the BIOS or something, right?
That's exactly right. And the same thing as well, like everything in the open source community is put together by people like myself on the internet, where we've reverse engineered things, so things aren't going to be 100% perfect. When we're talking about like a paid for software platform such as some of the others that are out there, they come with tech support. When you're in the open source community, there's no tech support. The tech support is the people on the forums, the other people that are happy to answer questions, provided you supply them with the information. You can sometimes get a little stuck. Yeah, that's why a lot of our business is unbricking and unlocking as well.
Yeah, that's what I was going to ask. If I end up breaking my ECU, we can come to you for help, isn't it?
Yeah, that's right.
And maybe send it in, or maybe just diagnose it over the internet. Because you're based in Melbourne, I'm in Sydney. How do we get it fixed if that's the case?
Yeah, so whether you're in Sydney or you're in North America or anything like that, I have customers around the world where they literally just pull the ECU out of the car, ship it over to me. I same day turnaround service, flash it back and post it back. We do a full test of the ECU before posting it back, to make sure that it's fully functional, and you get a fully working computer when you get it back.
Well, good. So we've got here Sean doing a little diagnostic for my H6 Liberty.
Yeah, just doing some quick data logging. We've got the cable plugged into the OBD port under the dash, and we've pulled up the ROM Radar open source program for data logging. We've got some live data on the screen for this particular car. We've got our IAM, we've got our battery voltage on there. So as I was talking about before, battery voltage is definitely important to make sure it's above 12 volts before we start reading and writing. We're not going to read and write today, we're just going to pull some information out of the ECU and see what the car's sort of learnt over time itself. So when I say over time, we're looking at air fuel corrections, as well as feedback knock corrections, so long-term feedback knock corrections. In the short term, the ECU is continuously monitoring for knock events, and in the long term, if the knock events occur around the same load ranges and RPM ranges continuously, Over time, the ECU will learn, oh, okay, I need to pull timing out, or I can actually add timing in that particular spot. So what we can see here from this one, we get all the information of the ECU. We've got the Cal ID, ECU ID, description of the vehicle, so 2007 ADM Liberty manual, battery voltage again. We've got our air fuel ratio learning over the ranges, and we can see that bank 1 and bank 2, they're actually out of balance. So it looks like maybe one of the O2 sensors could be a little bit on the skew there, given that one bank is say 7.3 and then the other bank is minus 0.9. It could either be maybe a vacuum leak in the intake manifold, sort of after the throttle body, or somewhere in maybe the exhaust, so possibly leaking out the exhaust flange, that sort of thing. With these cars, like this car has 126,000 Ks on it, so maybe it hasn't really had that much, you know, regular maintenance, that sort of thing, visual checks, that sort of thing done on it. Lower K cars are always, you know, a bit iffy, just like higher K's cars, and their maintenance and that sort of thing. But here we can see the knock corrections over time. So the ECU sort of picked up, oh, I need to take out some timing around 0.6 engine load and 4,600 RPM, and 0.8 engine load, 3,800 RPM. So yeah,
that's funny thing, because I've not had an engine code, but you're actually reading more than what I've already, like what I thought I knew.
Yeah, that's it.
Like,
so without, that's what I'm saying, without plugging in and reading out the data that's in there, we're not even running the engine at the moment. We're just looking at what's stored in the ECU. So without looking at this data, we can't first see how the engine's been performing in its past life before we go and make adjustments.
The only thing I suspected when I was driving was just seeing how my fuel efficiency wasn't there.
Okay.
Yeah, that's the only thing that made me curious as to why is that's the case, but there's just no engine faults. But I think you've narrowed something down there.
Yeah, that's it.
So what are these figures meant to be, like, around the percentages?
So percentages of air fuel correction. Ideally, we want zero corrections throughout the whole load range and RPM range and airflow range. But zero is an ideal world, you know.
But as long as you're close,
it's never going to happen.
To it.
The ECU, so long as it's within plus or minus, 10%, that sort of thing, the ECU is happy. So that's why our IAM has stayed at 1 for the knock correction. So the knocks sort of occurred, but not occurred enough that overall, for the entire load range and RPM range, that it needs to take out timing. So there's a little bit there, it's compensated for it, and it's happy. So that's fine. If we were to tune here, we could take out a bit of timing in these areas. But
in this case, you would suggest that I probably look into the leaks first, whether it's a manifold leak or an exhaust leak, before I probably do up the figures.
Yeah, that's right. So the next step would be to sort of turn on the car, do some data logs while driving and sort of cruising, and get an idea of, you know, whether or not the O2 sensors. So we've got AF sensor 1 here. It's 14.7 with the car off, but the idea would be see what it's doing in a live view, log it in the different load conditions, see if we can replicate these conditions that it's sort of picked up over time.
Gotcha.
After that, once we've got an idea of, you know, what it's currently doing and where it's sitting, we might do an ECU reset and then see what happens when it goes from a clean slate and tries to relearn all these values, whether or not they come back. It may have never been reset since the car came out of the factory.
Right.
So basically these values may be phantom. They might not have occurred recently, but maybe back in its past life at some point between manufacturer and now, it's decided to pull these out and make these adjustments.
But that will still affect how the car drives, because it's learned from previous...
Yeah, that's right.
You know, the way the engines run it.
Yeah. So there's lots of different things. We're just looking at the car at the moment with it turned off. We'll do some, you know, with the car running, that sort of thing, and then before you make any adjustments, you want to be happy with it. Yeah. And we get some more data on the screen. So we can see the current air fuel ratio here. The car's obviously warming up a little bit, current coolant temp. 67 degrees, so we'll let it warm up a little bit. From a startup, the O2 sensors will sort of heat themselves up. That's how they work. It's a wideband O2 sensor in the front, so it needs to first heat the element up, and then it will take stable readings.
Yep. Before then, they do what do they call, like a closed or open loop thing?
Yeah, so on startup there'll always be some sort of open loop startup.
Open loop,
so open loop is when it's just going by the values that are in the tables stored in the ECU calibration or the tune.
Because the sensors aren't ready yet.
Yeah, that's it. They're either not ready or they're being ignored. So we can see now we're at idle speed of about sort of 850 to 850 RPM or so at 75 degrees coolant temp, and we're making small sort of 1-2% air fuel corrections. Basically, as the car heats up, the RPMs will go down because that's what's set in the calibration. And yeah, looking at all the timing, everything like that, we've got no feedback knock at idle, so
that's a good thing, isn't it?
That's definitely a good thing.
I'm not sure how well the camera can see this, but we'll see when the video comes out.
Yeah, I might just take a quick screenshot for you and I can send it to you, put it in there.
Awesome.
So other things we can see with this software, it's using the SSM protocol, so we can see the intake cams. We've got intake VVT advanced left and right for both banks. That's something that most sort of data loggers that are off the shelf can't see because they can't read things that are on the SSM protocol.
Right.
So SSM meaning Subaru Select Monitor, special data that comes out. It's not CAN bus, it comes out on a different interface on the OBD port, and you have to have the right cable to read it out.
Yeah, gotcha.
We've got all these parameters on the left hand side here that are in this sort of definition for this ROM and ECU that we're connected to. So we've still got our calibration ID down here, and so ROM Radar knows that for this calibration ID I can monitor all of these things. So we can turn these on and off as we need, and we can see our variable valve lift mode at the bottom, 1, meaning not lift.
Not lift, which is good.
Yeah.
It's not running like at that RPM.
Yeah, that's it. Depending on the table and how it's set up in the tune, the variable valves, they might advance and go high, say from 3,500 or 4,000 RPM, so you get more performance and more airflow, that sort of thing.
So the car is fairly warmed up by now.
Yeah, so we've got 85 degrees up here. We can see our coolant temp. We can actually hear the aircon compressor clicking on and off, and we can also see that when that happens, our idle speed is going up and down. So we're about 900 when the AC turns on. When it turns off, it's about 850.
Yeah. There's a bit of parasitic draw from the engine speed, is it?
Yeah.
Just from the AC turning on.
Yeah, just from the ancillaries turning on, because they're all belt driven. So yeah, there'll be a bit of a loss there. We've got our manifold vacuum down here, so we're currently at sea level. Sea level meaning 14.65
the atmospheric pressure.
Atmospheric pressure, yep. So we've always got a bit of vacuum because it's a naturally aspirated engine. I guess no matter what the engine is, it's always got some vacuum sucking air in at idle. Unless we go up in the RPMs and start to increase some boost if we've got a turbo or a supercharger. But it's pretty healthy. -10 is what we like to see for this particular engine with stock cams. Obviously, if we had aftermarket cams or that sort of thing, the vacuum may be a bit less. If we're talking about, you know, like ghost cams or, you know, sort of phantom cams or that sort of thing, the big lumpy idles, we might have a low vacuum there of say -6 or so. Really the vacuum will be around whatever the heads and the cams are set up to be for that particular car at the time. So this being stock, -10 is what we want to see.
Great.
And our current intake air temp, 38 degrees. So that's taken from the mass airflow sensor in the airbox.
Yeah.
So it's pretty enclosed in the engine bay. That's why
it's affected by engine heat as well.
Yeah.
Plus we're running at.
That's right. It's
I guess there's no engine temperature for these models. Just coolant.
If you were to start driving, you'd sort of see that come down to around sort of 20 degrees or so on a day like today. It's pretty cold here in Sydney today.
So is there any other metric that we need to look at or to diagnose or anything?
Not particularly.
That's running okay at the moment. Yeah.
It's running okay as a bit of a stationary sort of health check. We can see the sensors are pretty all right. Obviously feedback knock, it's good to be 0 at idle, but we'd want to see how that sensor performs, say when we go for a drive, put it into, you know, 5th gear and sort of put the foot down from 2000 RPM and see.
The data logging is, how much data does this actually save, roughly, you know, how many drives, or it's just throughout its whole life, it's able to capture that much information?
So the ECU will capture only what it needs to capture, so the air fuel corrections over the load ranges and the feedback knock to create the fine learning long-term corrections.
Okay.
That's about it.
So it might not have data from way back. It might not.
No. So these particular ECUs don't have data from way back. You know, people often think, oh, it's going to know if I turn off traction control. No, they don't keep track of that sort of thing. You'd need terabytes of storage to capture that.
Well, it's good to know that my car is running smooth and fine as of today. Really appreciate your time with us today, Sean, from Sick Chips.
Thank you.
Thank you.